Assalamu alaikum warahmatullah, طلاب IGCSE. We have a famous question in transformation asking about the matrix that represents a given transformation like this one. This matrix 0, 1, negative 1, 0. What type of transformation? Is it rotation? Is it reflection? And what is the type of transformation? So to answer this question, simply you write the identity matrix 1, 0, 0, 1, okay? And you look what happens to this matrix to be 0, 1, negative 1, and 0. So the first vector I, 0, 1, and the second vector j. The I, as you know, is a unit vector in x direction, and j is the unit vector in y direction. So the first vector 1 and 0 is still becomes 0 and 1. Look what happens. This 1 and 0 becomes 0 and 1. Here, look what happened. Consider it's rotated like this, 90. And the 0 and 1 j becomes a negative 1 and 0. This is negative 1 and 0. So even j is rotated 90. So you just say or write its rotation about the origin point with angle 90 degrees, with angle 90 degrees anti-clockwise. Anti-clockwise, thank you, that's it. Anti-clockwise. So when let me give you some ideas about all matrices. For example, I want to write the matrix that represent the reflection in x-axis. You simply just write 1, 0, 0, 1, the identity matrix, and reflect these two vectors in the x-axis. Look what happened. This vector I is still the same because it's a reflection line still x-axis. So I is still the same 1 and 0. But the vector j, 0 and 1, will be reflected here on x-axis to be 0, negative 1. That's it. So this matrix represents reflection in the x-axis. Consider now reflection in y. Do the same operation, 1, 0, 0, 1, and reflect the I and j in y. When you reflect this one in y, this is the y direction. The I will be here, will be negative 1 and 0, and j is still the same because it's a coincident with the reflection line y. So 0 and 1. Thank you. That's it. Okay. For example, I want to write the matrix that represents reflection in the line y equals x. Also, you write 1, 0, 0, 1. This is the beginning point on all the identity matrix. And look what happened to the I and j, g, and I. This is the I, this is the j, and I want to reflect in the line y equals x. When reflecting I in the line y equal x will be j. Yes, will be 0 and 1. When you reflect j will be I, 1 and 0. This is a reflection in the line y equals x. Reflection in the line y equals negative x. Draw the 1, 0, 0, 1 identity matrix, and look what happened to the vectors, unit vectors I and j. This is the line really that represent y equal negative x. Look, the I will be here. The I will be, this is 1 and 0 will be here, will be 0, negative 1. And the j, this one will reflect it to be here. Look, here and here. Will be negative 1 and 0. Thank you. This is a matrix that represents a reflection in the line y equal negative x. Let's take, for example, the rotation about the origin with 90 degrees, okay, or with negative 90 degrees. How can you write it? So just write 1, 0, 0, and 1, okay, and rotate each of I and j. This is I, and this and j. Rotate each of them in about the origin with 90 degrees clockwise. So this is I, this is j, and the I rotated negative 90 will be here, will be 0, negative 1. J rotated 90 will be here, will be 1 and 0. Thank you. That's it, and so on. Rotation also is 270. You can do the same rotation about the origin 0 and 270 degrees or positive means anti-clockwise. Write 1, 0, 0, 1, and rotate each of them to 70. So this is I, this is J, and rotate I to 70, 90, 90, 90 will be here. So I will be 0, negative 1, and the J rotated also to 70, 90, 90, and 90 will be here, will be 0 and 1. Sorry, 1 and 0, sorry. 1 and 0. Finally, I'd like to talk about if you have enlargement. If you have enlargement meant with a scale factor, only 1t, sorry, with a scale factor like 2 or 3. So enlargement, the center is 0 and 0 with a scale factor k. Just write 1, 0, 0, 1, the identity matrix, and to multiply it only by this k factor will be a k, 0, 0, and k. This really enlargement with scale factor k. This only just idea about how to find the matrix that represent a given transformation. Thank you so much, and see you next time. Goodbye.